The second derivative test, concavity and finding points of inflection. Finding relative extrema, maxima and minima will be part of this. If you missed the first derivative test, it is at and is the link. You can just click on it and watch my other video. And please notice the subscribe button below. And I appreciate those of you who will be pushing that button. Thank you. Now, first, a few definitions. Concave upward. A graph is concave upward if it opens upward, like a bowl. And here's a picture of what concave upward might look like. Concave downward. The graph is concave downward if it opens downward, like an inverted bowl. And here's a picture of that. A graph of a function is concave upward if the second derivative of the function is positive. And a graph of a function is concave downward if the second derivative of the function is negative. But now we're looking at how fast the derivative is changing. If at a point the first derivative is 0, then that comes from the first test, and the second derivative is negative, the function has a relative maximum at that point. So first we get the candidate for relative maximum, the first derivative is 0, and then we check the second derivative. If at a point the first derivative is 0 and the second derivative is positive, function has a relative minimum at that point. Looks counterintuitive. Negative goes with maximum, positive goes with minimum, but it has to do with how fast the derivative is changing and in which direction. Well, what happens if the first derivative is not 0 and the second derivative is? The concavity changes sign at a point where the second derivative is 0 and the first derivative is not. So we go from positive to negative, we change concavity. We change from negative to positive, we change concavity. Point at which a concavity changes is called a point of inflection. So that takes care of the definitions. Well, what happens if both the first and second derivatives of a function are 0 at the same point? And now we got a problem. This makes the second derivative test inconclusive. The point could be a maximum, minimum, or a point of inflection. So then we would have to do something else. And so you might be thinking, well, it must be a kind of complicated function to do that. But no, it's not. Think about f of x as x to the fourth. Kind of looks like a parabola, but not quite. Its first derivative is 4x cubed, and its second derivative is 12x squared. Both derivatives are 0 at x equals 0. So here we can look to the left and right of x equals 0 and see the concavity is upward on both sides. So 0, 0 is a minimum function. It's concave upward, and this is just a point in that concavity. But let's think about f of x equals x to the fifth, an odd exponent. Here the first derivative is 5x to the fourth, and the second derivative is 20x cubed. Both derivatives are 0 at x equals 0. Here we can look left and right of x equals 0 and see the concavity is upward to the left and downward to the right of x equals 0. So the point 0, 0 is a point of inflection. The concavity changed. Another place concavity might change is at a point where the second derivative is undefined. An example of a function with an undefined second derivative is that at 0, 0 is f of x is the cube root of x, or x to the 1/3. The first derivative is 1/3 x to the negative 2/3. At 0, 0, this does not exist because we have 0 in the denominator. X to the negative 2/3 is 1 over x to the 2/3. 1 over 0 is undefined. So the second derivative can't exist if the first derivative doesn't. So here we got a case with an undefined second derivative. For all other values in the domain, the second derivative is negative 2/9 x and negative 5/3. Left of x equals 0, the second derivative is negative, implying the concavity is downward. Right of x equals 0, the second derivative is positive, implying the concavity is upward. 0, 0 is a point of inflection. Another case is when the graph has a sharp point. Neither the first nor the second derivative exist. Here's an example of a minimum at a point. Well, just because I have a minimum, a relative minimum, does not conclude anything about the concavity. Because here we have concave down, here we have concave up, and so here we have a point right here that's both a relative minimum and a point of inflection.